Hi, everyone. Good morning, good evening, good afternoon, wherever you may be. Welcome to our live stream, and thank you so much for making the time to join us. My name is Keen Chen. I'm with the marketing team at VeloDB and Apache Doris. So we're super honored today to host this webinar with AWS. We have two experts today with us. They are Owen Xiao, Apache Doris PMC, and Product VP at VeloDB.
Hello, everyone.
And Dr. John Wenju, Senior Solution Architect at AWS.
Hello, everybody.
So in today's session, Owen will first talk to you about Apache Doris 4.0 and its new AI capabilities, including vector search and AI functions. These new features are essentially built to help you to do hybrid search, basically combining full text search, vector search, and structured analytics all in one unified SQL engine. So consider it as a one-stop shop data infra for handling AI and agentic workloads. And after Owen's talk, Dr. John will discuss how to actually use AWS services and MCP servers to build domain-specific data agents from scratch. He will also have a live demo showing you the whole process, so helping you to put everything all together. And lastly, just one small housekeeping note. We'll do a quick Q&A session after the two presentation. So feel free to type in your question anytime you might have. It is at the Q&A tab at the bottom of your screen. So we'll all address them at the end. So with that being said, I'll hand the mic to Owen. Owen, all yours. Feel free to start the presentation anytime.
Okay. Hi everyone, and thank you for joining. Today I will sharing some insights on real-time analytics in the agentic AI era. I'm Owen Xiao, VP of Product at VeloDB, and also the PMC Apache Doris open source project PMC member. Yeah. Okay. Today I'll talk about three parts. First, evolution of real-time analytics, and then let's discuss why Doris is a good fit. And finally, I will share some real customer stories in their production environment. I hope that will help you. So let's first start with the evolution of real-time analytics. The real-time analytics has its evolution from three stages, from the internal user-facing analytics to external-facing or customer-facing analytics, and now the AI agent-facing analytics. For the internal user-facing analytics, the typical use case is BI and dashboard, and some kind like user behavior analytics is designed for users inside the company. And the external user or customer-facing analytics is designed for users from outside of the company. For example, for the SaaS company, their customers may need some analytics on their website. For example, the order and analytics, inventory analytics, and like that. And for AI agent, there are more analytical requirements or needs. For example, chat BI, data agent, and some domain-specific agent. For example, digital marketing agent. So, what's the different requirements of three kinds of real-time analytics? And I think that from the internal user-facing to external user-facing, the most different thing is about there are more users outside of the company or your customers. The number of users increased dramatically from hundreds to thousands or tens of thousands. And the users are a lot of the external users are a lot patient. They need to see the analytics results in seconds or even sub-second. And when it comes to AI agent facing analytics, I think the number of users became, or the number of agents is much larger than the customers. This is the first difference. And more important that more intelligence is needed for AI agent. For example, the full text search, vector search, hybrid search, something like that, because AI agent need to deal with the unstructured data. And the interface from the agent to database changed from JDBC, ODBC drivers to MCP, Model Context Protocol. Okay, with that context, let's look at why Doris become a popular choice for the agent-facing analytics. I think the first reason is real time. It's about fast, it's about low data latency, very fast query response in second or even sub-second, much higher concurrency, for example, thousands or even hundreds of thousands of concurrent queries, and high availability with zero downtime. Doris consistently rank among the fastest analytics database across major benchmarks. For example, the single table benchmark Clickbench and multi-table benchmark TPCH and more complex multiple table benchmark TPCDS. And in the AI era, the data is not only in structured table, but also some unstructured and semi-structured data, for example, JSON. So Doris variant data path is designed for high performance semi-structured data and analytics. And you can see that from the JSON bench, Doris is number one for code. It's the first, the time of the first run for the queries. And number two for hot run is second and third run time. It's very fast for JSON. And not only for query, for the update of data, Doris is up to 25 times faster than K-House in real-time update. It is very important for workloads with frequent updates and near instant analytics demands. As we know that data is not static, many of the real-time data need to be updated. And about cost, Doris is still the most cost-effective option. For example, compared to Snowflake and ClickHouse, in Coffee Bench, it's 5 times more effective than Snowflake and 3 times more cost-effective in ClickHouse. And as you can see in TPCH, TPCDS, we've seen the much better result. Okay, after we talk about the real time, let's go to the most important one, intelligence. That's why users choose Doris in the agentic AI era. About intelligence, Doris 4.0 version provides 3 important features. The first is hybrid search. Doris support structured filter and full text search for years. And in the latest release 4.0, vector search is supported, and you can do hybrid search in SQL in Doris. And second important feature is LLM functions. You can call LLM in SQL. It's very important that you can. It's more easy for the users, not just engineers that can write programs. So you can use call LLM in SQL with effortless. And the third is MCP server, since this engine talk to database without JDBC or ODBC. There is a standard protocol, MCP protocol. So Doris also supported that and explores the tools about query execution, meta discovery, and something like that. Okay, let's go deep into the features. First, about vector search. For the unstructured data such as text, image, audio, video, you can convert them into a vector using the embedding models. And then you can search for a similar embedding using vector search, vector index, and vector search. Before 4.0, Doris support vector search by brute force computing. It's not fast, and so in 4.0, vector search, vector index such as HSNW is supported, and you can do vector search much faster. I think 100 times faster than before. And full text search is also supported in Doris for years. For example, it supports multiple tokenizers. For example, for the Unicode, you can use standard tokenizer, ICU tokenizer, and for Chinese, you can use IK. And Doris supports multiple full text search functions. For example, match any of your keywords, match all of your keywords, or match your phrase. And then a unique search function that support analytics search SL is supported in Doris. So if you use Doris, you can replace Elasticsearch. You don't need to maintain two systems. It's very important for a log and content search for the data agent. And in 4.0, Doris added the BM25 score feature in full text search. You can order by the relevant score of the match result, and you can get the most relevant documents you need. So after vector search, vector index is supported, Doris has completed the graph of hyper search. For example, in this SQL, you can query the data. Update time between days, it's a structured filter, and the description match GNI, it's a full text search, and order by the cosine distance, it's a vector search. So you can combine vector, full text, and SQL search just in one SQL. It's very convenient and efficient. Okay, let's go into the AI functions. Doris has built-in AI functions to integrate with major LLM providers such as OpenAI, Anthropic, Gemini, and DeepSeek. It's very important that users can call LLMs with SQL directly without writing any code. It's more easy to use. And last, let's see the MCP server. The AI agent talk to database using the model context protocol. So Doris supports this kind of protocol and explores the query execution, metadata discovering, and some management functionalities to the AI agent. Okay, and last, let's look at some real-world examples of these capabilities in production. The first user I want to show is Minimax LLM observability. Minimax is a leading LLM company and also the creator of Talkie app, which is very popular in US. The new log system based on Doris has been integrated to other log data in Minimax, supporting petabyte scale storage, 10 gigabytes per second real-time ingestion, and second-level query latency. For the LLM application and model companies, there are a lot of logs, trees, and other observability data generated every day. It's also very important to manage this kind of observability data efficiently with no cost. And the second user story I want to share is Tencent Music Content Network. The chat BI system called Supersonic based on Doris. They replaced ES, Elasticsearch, and CleanHouse with Doris for content library, achieving both the search and analytics capabilities. This is very important for the chat BI and AI agent analytics workload. And additionally, the using Doris reduce 80% of storage cost and 4 times improvement in write performance. Using Doris, they enhanced LLM OLAP interaction efficiency and result accuracy, ultimately enable a more intelligent question answer experience. And many users are using their supersonic system to ask questions about the data in the enterprise. Okay, and the latest user story is very interesting. ByteDance built their AI data and AI platform, DataMind. In fact, the vector index and relevance score features of Doris 4.0 is contributed by ByteDance. They built the vector indexing and full text relevance scoring on top of Doris and contribute these features back to the community. It's a good example open source. Okay, it supports a hybrid search, meet the RAG and graph RAG requirements of multiple business scenarios. I heard that there are more about 7 use cases are in production for their internal use cases. For example, RAG, both the naive RAG and the graph RAG. Many business lines are using the RAG service backed by Doris. And the second kind of use cases is enterprise data agent. They developed an Ask AI data application to allow the users to ask questions from the data more easily. In using Doris, it can automatically accelerate the query on DataLake by Doris superfast lakehouse query engine. I think so fast and real time is very important for data agent. And they also integrate the privilege control system to avoid risk problems. And the third use case is about content governance. They use core AI functions to tag in some videos and content moderations. Use hybrid search to search for historical cases or some historical content to help them to do some analytics and decision making. And more use cases are going online in ByteDance. So I think it's a very good example. Okay, that's all I want to share. Thank you. Okay, if you have any questions, you can post on the webinar and we will answer.
Yeah, we're seeing a few questions already in the Q&A tab. I see Dr. John has already answered one from Oscar. We'll address the Q&A in the end. So Dr. John, whenever you can start your sharing now.
Yes, let me share my screen.
Okay, I will stop.
Okay, let's wait a moment. Okay, can you see my screen right now?
Yes.
Okay, great, thank you. Let's get started. Good afternoon, good morning, good evening, wherever you are. I'm Wenju from AWS. It's my pleasure to share a data agent on AWS topic today. And firstly, I will introduce the recent history of data agent, actually a very short history, then leave them for you, and then talk about the architecture, how to build data agent from scratch, and finally discuss the future of data agent. The first, slide is about the short history of data agent. Years ago, ChatGPT can write circle. Given table structure, it's simple text to circle scenario. Most of the time, the algorithm can't get enough context for the generation of circle. So RAG can be used to enhance the context for circle generation. It can improve the accuracy for sure. With function call or two use of LLM, we can also execute the circle after generation immediately. So here comes a data agent. Nowadays, we can build powerful data agent with agentic LLM. It's much autonomous, goal-oriented, adaptive AI system for data analysts. I'd like to give you two demonstrations for agentic data analysts. The first one is about using general coding agent for data analysts. Just as you can see here is a snapshot of the demo. And maybe this surprises you at first glance. How can we using agent for data analysts? Let me show you. I have some data in the data warehouse already. So here, this is my Kiro. Have you heard of the Kiro? It's a coding agent, AI IDE, developed by AWS. Right now, I have several MCP server configured in the left side of the IDE. Today, in this demo, we just use one MCP, the Redshift MCP server. There are several tools available for this MCP server. Okay, we just only have MCP server, no other configuration needed. Right now, I just input some sentence in natural language, analyze ARR by industry from Redshift. I need to tell the agent to find some data from Redshift serverless. Okay, I just input one sentence. The agent will explore the data structure and try to find the table structure and get the related table information, and then get the data, generate the circle and execute the circle, and finally get the data. So this is a very long trajectory of the agent running like this. I just run the demo already. Let's have a look. Yeah, this is a trajectory of the agent running. As you can see here from the chatbot, and you can click to check what function call the agent used. Here is a list database, and finally, the agent can find the data in the data warehouse and then generate the circle. like this. Yeah, here is a circle generated, and then execute the query immediately after generation and get the insight from the data warehouse. So this is the first demo for us using general coding agent for data analysis. Actually, you can even use AWS command line to analyze data without using MCP server at all. From this demo, we can see that the model, the underlying LLM, did a lot of works to find the related table structure and generation of circle, and finally execute the circle. Let's have a look at the second demonstration with UI. So in this demo, we have the same data in the same warehouse. Let's go to the web. We have a web UI already there. Yeah, as you can see here, we have a data agent web UI, and we have the same data with the first demonstration. Here, I just input analyze ARR by industry. This agent will do a lot of exploration and finally give us the data like this. You can also see the chart like this. So here's a chart that I'm generated for us using the visualization library. So here's a second demonstration for us. Okay, from the demonstration, you can see the simple query of agent is very straightforward. And how can we build this data agent using AWS services? This is a high-level architecture for this data agent we built in the demonstration. And so the core part is a strengths agent here. And we built the agent using strengths agent SDK and deployed this agent on agent call runtime. So this is a Bedrock service, managed service for running agent. Regarding the data sources, we analyzed, actually, you can connect to any data source if you want using data API, JDBC, MCP server, or even bash shell command. For instance, WillowDB, introduced by Owen previously, can also be connected using MCP, JDBC, etc. So this is a typical data agent architecture. For sure, we also have a web interface built using AWS Amplify. Just I showed you in the demonstration. Okay, this is a architecture. Let's go to Strengths Agent SDK. Then, what's the strength? Why we developed and open sourced the Strengths Agent framework? There are many agent frameworks in the market already. Why it is built one as well? So we aim to provide developers with powerful, flexible tools to build agents in the rapidly evolving agent landscape. And it's quite simple to build agent using Strengths SDK. Just a few lines of code. I can show you in my demonstration, what code we developed. And the core concept of the of strength agent SDK is agent loop. What's agent loop? Maybe you have heard the agent patterns, eager workflow, or agentic loop. Both patterns have their own usage scenarios. The agent loop is a core concept in the strength agents SDK that enables intelligent autonomous behavior through a circle of reasoning, tool use, and response generation. The agent loop is a process by which a strength agent process user input, just like I input analyze ARR by industry. So the agent will make decisions, execute tools, and generate the response. It's designed to support complex multi-step reasoning and actions with seamless integration of tools and language models. So it's a core concept of strength agent SDK. What's regarding the customer of the strength SDK? The first customer of strength SDK is its internal AWS team. The Q developer team is building and launching the product using strength SDK. Actually, we open sourced afterwards as an open source project. So they are hosted on the GitHub already, and you can go to the GitHub to find more details about the strength SDK if you like. And yes, there's some built features for the SDK support. The SDK supports multiple models, LLM models, and it's also highly flexible to integrate its external systems such as Langfuse for observation. And we also built a lot of built-in tools for the SDK. For example, the MCP integration already there, and a lot of tools available for us to use. Definitely, you can build your own tools just using simple Python functions. So these are high-level features of this SDK. Let's have a look what we developed in our demonstration. The core code logic is here. We declared a bedrock model. Actually, you can use different models. For example, you can use a letter LLM as a proxy to connect any OpenAI compatible LLM, etc. And then we define an agent like this with some conversation histories as a message parameter, and with the model we declared, and a system prompt and hooks like memory functionalities. So you can have the memory using hooks as easily just one line of code. And yeah, the important part is the tools. Here we gave 3 tools for our data agent. The first one is get tables information. So the agent can get the table information by themselves, by itself. And another one is the current time. The agent can get the time at real time. The third one is execute the circle query against the data sources. In our demonstration, so the agent will get the table related information, then generate the circle, and finally execute the circle to get the data. And afterwards, the agent will generate the response based on the circle result. So we will get some insight from our data warehouses in this way. This is a core part of our logic in the database. in our agent using our agent framework. So where the agent run, as you can see in the demonstration, we don't know. Actually, we don't know where the agent runs and how does it runs. Here comes agent runtime. We deployed the data agent on agent call. What's the agent call? As you can see here, the agent call is a managed service enabled developers to build and operate their agent on these managed services without the heavy operations, etc. And there are several components available in this managed service already. So actually, in this demo, we're just using two components. The first one is a runtime. Another one is a memory. What's the runtime? As you can see from this diagram, you can build the agent using any agent framework with any language, program languages. And after then, you can build the Docker image, and then you can deploy the agent on Bedrock agent call runtime. So in our demonstration, I already deployed the data agent on the agent call runtime. And when we input some query or natural language queries, the agent will get invoked. And then the service will be provisioned immediately using lightweight VM. This is a simple process of the mechanism, the agent call runtime. And in the agent call, there are also some components here. You don't use. I want to introduce the components for you as well. This is an identity component for the authentication and authorization of the agent, even for the service-to-service authentication and authorization, and the gateway component. For gateway component, we can bridge the open API interface and between the MCP. So actually, we can expose any Lambda functions, open API interfaces as MCP server using gateway of the Bedrock agent call. And another component is code interpreter. So here, as you can see from the name, the code can be executed in this component. So the algorithm can generate a lot of code. We can run the code in your demo in your own development machine, but in the real development, in the real production environment, you need to run your code securely. So the code interpret is a runtime, is a component. You can run any code, any language generated by the algorithm, and then you can also get a result using the API from a code interpret component. And another component is the browser tools. So as you can see here, we have one tools here, list here. Actually, there are many tools will be available in the future. So the agent can use any tools compatible with the MCP, or even you can using the code to call your functions to call any tools. Browser tools is just one kind of tools. You can browse the internet using the natural language. So in this tool, the browser tool will open a browser instance to visit any URL you designate. And here you will get the result after calling the web. So for instance, you can search Google and get the information for the deep research scenario, etc. And finally, there are one more component about the observation, and you can see the call stack and the traces and logs in the battle agent call web console. So this is a battle agent call component we used in our demonstration. And in the big picture, let's break down of the technology stack building a data agent using AWS services. We just used this one. So here, as you can see from here, Strength Agent SDK. We also use the agent call of the Bedrock. So we just used these two services from AWS. Let's have a look at the big picture of AWS offering for agentic AI. Whether you are looking to quickly deploy pre-built agents to boost productivity, experiment with open source tools, or build a fleet of sophisticated customer agents, AWS provides the models, the tools, infrastructure, and expertise to help you succeed. So this is a high-level offering of AWS in the agentic area. Okay, regarding the future, just I showed in the demonstration, it's a quite simple query to get some insight from our data warehouse, data database, or any other data sources, etc. There are also some challenges when we build agent for real business scenarios. For instance, the knowledge of your business usually it's in your own knowledge base, in your own repository, in your own system. The domain expertise is also out of the knowledge of LLM. So to process the complex data analyst tasks, you need some knowledge base of your business. And security and the permission management is also the challenges as well for the real production environment, etc. In terms of the agentic AI for the data agent, we also have 5 aspects, just like this diagram. So from perception, so it's quite important. The agent can perceive the environment and get the information from the environment, and then planning to do some task decomposition and reflection and reasoning, etc. And then acting. So the agent can use tools to get more information from your system, from your ERP system, from the CRM system, etc. And with tools, you can even get more information as well. And finally, it's about memory. So the memory is also very important part of the agent. You can build a simple demo, but without memory, you can deploy in the real business scenario. For example, if you want to develop a customer service agent, the agent can remember the customer's call histories. Yeah, it's a very good experience for the end user. Otherwise, the agent will forget the conversation history. The customer will get some outdated information. The customer need to input their information again and again. So the memory part is also very important for the data agent. And at the moment, we are actually at the point of level 2 or level 3 agent phase. In the future, definitely we will have level 3 or level 4 or level 5 agent for more intelligent data analysts. Looking forward to full autonomous data agent area. This is a survey paper actually outlined the different levels of the agent. Okay, looking forward to the fully autonomous data agent in the future. We can deploy in the enterprise. And thank you very much. This is my sharing for today.
Thank you so much. Thanks, Owen, and thanks, Dr. John, for the detailed presentation. We definitely look forward to for a future where we'll use more data agents in all of our daily pipelines. And here on screen, obviously Apache Doris, as a real-time data warehouse, we are providing the data infrastructure for the agentic AI and the data agents future. So if you wanted to learn more about how to do vector search, how to use our AI functions in your SQL engine to do all of these data agents workloads, feel free to join us, the Apache Doris community. We have a lot of users, a lot of experts, a lot of know-hows to share in the community. Join us on Slack. And also feel free to subscribe to our mailing list. Our Slack is the QR code on the right. So Slack is really the best way to reach us. And also, you can find us on LinkedIn. We are VeloDB on LinkedIn, and we share Apache Doris knowledge almost on a daily basis. And I also just launched a poll to just gather some feedback from you guys. I would love to hear how you think about the webinar and what kind of other topics that you would like us to talk about. And also, if you have any more questions, feel free to type in the Q&A tab. We'll give you guys a few, just 10, 20 seconds. And in the meantime, I'll probably read out the questions that have already been answered. So Oscar asked, what would be a valuable use case for calling an LLM in SQL, and what format would you expect the response to be in? And Dr. John replied that you can do in-database AI analysis with LLM call. For example, suppose you have customer reviews data in ValueDB. You can analyze the sentiment using SQL call LLM in database directly. Owen, do you have anything to add to that question? What are some other kind of use cases that people can use calling LLM in SQL?
Yeah, I think the first point is about convenience. The user can don't need to write code to call LLM to read data from the database and call LLM. So it's much more simpler. And the second is that you can combine the power of LLM and database. LLM can do the unstructured data analytics such as summarize, and then you can use database tools such as structured analytics. You can combine the power of both. So it's more easier and more powerful. Yeah.
Gotcha. We got a new question from Oscar.
Yeah.
Dr. John or Owen, does anyone want to take that?
Yeah, I see the question from Osaka. Thank you. So let me try to answer some part of the question. Actually, you have several options to do the sentiment analysis in the database, and you can export the data to external storage and do the analysis. So this is one option. Another option is about in database analyze. So you can call external LLM API using a VeloDB LM function. So in this way, you can easily do the sentiment analysis without exporting your database to any external storage. So I think this is the biggest advantage for this function usage scenario. Yeah, Owen, you can also ask.
Oscar talks about cost. Yeah, in fact, for some simple tasks, the large language model are very costly than the simple models. But for some cases, LM is much smarter, more intelligence, and give more accurate result. So it depends on you. Yeah, depends on the user to choose between LM or the small models.
I also want to recommend to use Amazon Nova LLM model to do the sentiment analysis. It's very powerful. Yeah, you can try.
Gotcha. I think Oscar just replied that I see this is about flexibility and breadth of skills. Thank you both for your answers. Yeah, so we are almost close to our runtime. I'll give five more seconds if you have any questions.
I'd like to explain more about the Andres question. What's the benefits do I have with VeloDB offer on top of Apache Doris? In fact, Apache Doris is an open source project, so it's totally free. And VeloDB is a commercial product, which is more professional. So we have you can get the benefits as below. The first VeloDB provide fully managed cloud service on public clouds such as AWS cloud. Yeah, so you can use it out of box. You don't need to manage the cluster. And second is compliance and security, and SOC2 and Hyper and others. It's more easy to be compliant. And the third is we provide web console for cluster management and data ingestion and query editor, and it will provide more features that easy to use. It can be more easy to set up your database and more easy to use. And fourth is that VeloDB provides some endpoint features that's not including Apache Doris, such as transparent data encryption, transparent data transfer, and more features will be added. And finally, VeloDB provide professional commercial support from the experts of Doris community, since VeloDB is founded by the creator of Apache Doris project. Okay, so you can get more from VeloDB.
Yeah,
but if you prefer open source project, feel free to use Apache Doris.
Yeah, definitely. So yeah, feel free to try it out with Apache Doris. And I mean, VeloDB is always here. We are powered by Apache Doris. So another way to get in touch with us is always, good to join the community. So yeah, that's about it for today's session. Thank you guys so much for joining us. I know there's a lot of ways to spend your time these days, and thank you so much for spending your time with us. And thank you so much for Dr. John for your detailed, exquisite presentation. And thank you so much for Owen for your sharing. We look forward to see you next in our next session. We do have another new webinar next week on data variant. So, uh, feel free to join our group and look at our website, velodb.io. We will have a lot more information on upcoming webinars. Thanks again, everyone. See you next time.
Thanks. Bye-bye.
Thank you. Bye.
Bye.